Hi, this is Sungchen Chen. In this video, I would like to discuss about a project that was written by C programming language. This project name is called Numc. If you are familiar with NumPy, Numc might sound familiar to you because Numc is actually a variant of NumPy module. It also relates to the matrix operations. If we look at numc.c here, we can see that this is a translation from C programming language into Python programming language. So we have different Py objects such as Py tuple, Py list, Py long, etc., etc. And in this case, we have implemented different matrix functionality, such as matrix init, matrix deallocate, matrix addition, subtraction, multiplication, and power, negation, etc. But merely implementing different matrix operation is not enough. We have to considering one fact about NumPy. What is fun about NumPy? NumPy is really fast. It is much faster than the simple naive algorithm that we can do with matrix operation. So in this case, we have done a lot of optimization into the matrix operation. So we can take a look at it. If we open up matrix.c, except the functions such as allocate matrix and allocate matrix ref and the deallocate matrix, we have the functionality of things like fill matrix, add matrix, etc. Okay, so if we look at that, what we have now is that we have a SIMD operation. What is a SIMD operation? This is an operation that can be dealt with four pieces of data at the same time. Think about a tuple with a length of 4. If we want to add them one by one, we have to do 4 computation. But with SIMD instruction, it is much faster to just add them in parallel. So SIMD operation does optimize a lot. Okay. Well, the other thing we want to consider is cache. Why does cache important? Because different matrix have different matrix layout. One matrix might be implemented by column major, and some matrix might be implemented by row major. In our case, we implement our matrix by row major. In this case, whenever we fetch a block of data from a matrix, they actually show one by one by row major. So the data next to each other is actually on the same row. Okay. So this is an important feature whenever we're considering taking some data. We shouldn't take a whole column if we don't have to. We should always considering taking the row first instead of taking the columns. This could much fascinate the runtime and the performance of the matrix operation. So in fill matrix, what we have done is, first of all, we use SIMD instruction. We also considering cache. And another thing is that we also considering loop unrolling. So what is loop unrolling? Loop unrolling is actually unroll the loop into multiple instructions. This is actually be able to make our code faster because we don't have to jump back whenever we have a loop. We just execute each statement one by one. okay? And then the other thing we also need to consider, which also fascinates our code, is threads. We also use multi-threading. Why is multi-threading important? Because multi-threading is actually enable us to do the instruction in parallel. One thread can take care of some rows of the matrix, and the other thread is taking care of the other rows of the matrix. So this could be able to make our code much faster also. With all of this optimization, we will be able to construct a much faster matrix operation than the naive one, even though the theoretical runtime does not change. The theoretical runtime of every operation keeps the same, such as matrix add takes O n square time. Matrix multiplication takes n cube time. With that in mind, we can take a look of the mole matrix. In this case, we have separated things into different cases whenever we see the rows and columns. So in this case, we have a row loop unrolling, and then we have a SIMD instruction, and we have a pragma enabled here. What is pragma? Pragma is actually the parallelism that we have implemented within our function. This is the pragma with parallelism. With this enabled, our code will be much faster. So if we want to take a look how fast our code is, we can look at here. We can see the test name is called multiply benchmark. We have a 98 times speed up than the naive one, which is a great giant leap. And also, the other function we have successfully implemented and optimized is the power. Well, if we think about the matrix power algorithm, we can think of we multiply a matrix power times. So the runtime is going to be n cube multiplied by power. So that is really costly. In this case, we considering another technique that is really important, which is divide and conquer. So we split the power into two halves. And then finally, we merge those intermediate results together, which is able to give us a much faster runtime, which is in order of log of power. So the final runtime is n cubed times log of n, and then this is also much faster. And if we take a look how faster it is able to produce, we can see that it is 1,978 times faster. So this is much optimized than the naive one. And also we can see there's a simple benchmark and comprehensive benchmark. All of them, we have successfully achieved a full score, which is really important, and then which is really educational. I learned a lot from this project, not only in the optimization parts, but also in the C to Python translation, algorithm, multi-threading, SIMD, parallelism, and different technique of making our code faster than it should. So this is really important and really lucky. In the interest of time, I would like to conclude my Numc project. Thank you for watching. If you have any question, please contact me. I can answer them to my best of my knowledge. I'm looking forward to meeting you. Thank you so much.